Hello everyone, I'm Mustafa. I'm very happy to have you with me in this video. In this video, we are going to talking about a duplicated work order and try to answer some questions, key questions, like how they impact similar systems and why it is very important to us. And finally, we try to answer these questions. How can use ML, machine learning, to intelligently detect and prevent them. As usually, I will start by arising three fundamental questions. We will try to answer them in this video. The first question is, what exactly is a duplicated work order, and how does it differ from a similar work order? The second question is, why are a duplicated work order important to us, and how do they impact the CMS metrics such as revoking MTTR and NTBF? And finally, the third question is, how can we use ML to intelligently detect a duplicated work order in real time? Before everything, we have to emphasize this word. Duplicated workorder is very important in CMS. Because duplicated workorder lead to a big problem in our systems. This problem is one of the biggest hidden challenge in maintenance management, and it can be lead to wasting a 50 to 30% of the annual maintenance budget in a large company and large system like oil and gas. Now we have to focus on this question: why we have a duplicated work order in our systems. We have a duplicated work systems because of many reasons, like lack of visibility. Technicians are unaware of this collect previous work orders or no intelligence search capability in CMS, and a work order description are registered in a different language like a Persian or English. The second reasons that we have a duplicated work order is a multiple registration by a different users. We have a different user in a different shift, like a morning, evening, night, and we have a different user in a different department, like operation, maintenance, or inspections. And every user think it is a new work orders. The third reason that we have a duplicated work order is a lack of a standard classification. We have to use some factors and some item to classify our work order in our system. The most important factor can be a failure groups. By failure groups, we define a standard classification, in our under our work order in our systems. Now we try to speak about a negative impact when we have a duplicated work order in systems. When we have a duplicated work order, we have some negative impact in our CMS. The most important negative impact is a financial impact. For example, about a labor description is a technician do work again, or about a spare part, double consumption of a part, and downtime, equipment taken off the service again. And all of them lead to some negative impact, like 20 to 30 percent of budget are wasted, and 10 to 50% of inventory are wasted, and about a downtime duplicated lead to reduced availability. Second factor or negative impact when we have a duplicated work order is operational impact. Duplicated work order have a negative in a different, many different operational factors like MTBF. Duplicated lead to a reduced MTBF, lead to an increased reworking, and lead to a delay in real work orders. The other negative impact when we have a duplicated work order is a safety impact. And finally, about a report. When we have a duplicated work order, we don't have a valid report, and we cannot calculate correctly some KPIs like MTTR or availability or reliability. It is very important because everything in CMS is very involved around reportings, and when we cannot make valid reportings and we cannot use a CMS in our systems correctly and cannot cover CMS in our maintenance systems. Before everything, I want to show we can make a pattern in about work orders. For example, in a real statistics from a reported data, we identify a duplicate work order patterns like a GS chart, fan washing needs during overall external cleaning, mechanical stroke, and internal inspections. All of these patterns are identified, and after that we can calculate how repetition count, how many repetition count or happens in duration. For example, about a grease chargings, we have more than 80 work order repetitions counts during 6 months. These patterns help us to learn our systems based on a machine learning algorithm. And it is very important to us because patterns, identify the patterns, help us to use a smarter systems, a smarter intelligently systems to detect a duplicated work order in our systems. By analysis of this data and identify the pattern in our systems, we gain some information about systems, about duplicated work orders, and the most and help us to have a abstraction view about our duplicated percentage in our system. For example, we reach a 50 to 10 percentage duplicated is about a PM work orders, and 50 to 25 duplicated is about a CM work orders, and 20 to 30 duplication is about overall work orders, and overall average is 18 percentage duplicated. This number is very high, and we have to use some solutions to reduce this number in our systems. Generally, we try to use both of the traditional solutions and ML solutions to reduce this duplicated percentage in our systems. Traditional solutions using some method like simple text searchings, hard rule, manual review by a supervisor, and blacklist of words. As you know, this method are very important and help us to detect some duplicated work order, but it is not enough at all because this using a method have some problem. For example, a simple text searching doesn't find a clear as a term is called in a multilingual or about a manual review by a supervisor. Its problem is not scalable, and blacklist of work. Its problem is incomplete coverage. So we try to use a smarter solutions by using ML solutions. ML solutions help us to reach a capability like semantics understandings, type tolerance, multilingual detections, learns from the experience and real-time checking. This table helps us to have a compare between the traditional approach and ML power approach when in the different aspect. For example, in the when task identifications, traditional approach is a manual and based on a planner memory, but ML is this approach using that by automatic and based on the historical patterns. Time to create job plan in the traditional approach done about 50 to 30 minutes, but in the ML is done less 1 second. So traditional and ML, both of them useful to detect duplicated work in our systems. However, I think ML is a smarter and intelligent approach, but traditional approach is very necessary in us also. The next video we try to speak about how can develop ML in our systems. We can use ML.NET, we can use a traditional method to reach a complete module to detect a duplicated forces, a duplicated work order in a Eventex CMS. For reach this solutions. The next video we try to speak about the complete program, complete module, and I hope to follow us in the next video also. Thank you for attention. Thank you for following.